Hey class, in today's lesson we're going to talk about special angles, which is found in section T-2 of your book. Our objectives are to use the properties of 45, 45, 90 degree and 30, 60, 90 degree triangles, and to find the trigonometric ratios of 30, 45, and 60 degree angles. Sorry that that's not all there, but that's our real objective. All right, so talking about 45, 45, 90 degree triangles. Okay, so these are right triangles that as their acute angles, those acute angles are 45 and 45 degrees. Thus, adding all the degrees in the triangle up to 180. So to find their side lengths, if you know that their angles are 45 degrees, then it's an isosceles triangle. So the side lengths that are connected to those base angles of 45 degrees are just considered side, and then its hypotenuse is side times the square root of 2. For a 30, 60, 90 degree triangle, you just need to understand that I kind of look at it as 1, 2, 3. That's the best way I can say it, and really it's 1, 2 square root of 3. So it's 1s, 2s, and s square root of 3. So it's like you see 1, 2, 3. The 1 is going to go opposite of the smallest angle, which is 30, right? 60 is going to match with 3. So 60 degrees and 3, which is square root of 3, are going to match. 30 matches with the smallest one, and just remember that the hypotenuse is double of what's being asked. Okay. Also, these equations here kind of help, not kind of, they do help quite a bit. So if you can memorize them, they are a significant help when solving. So let's keep going. All right, so it says, what is the value of each variable? Okay, first of all, we should recognize that these are 45, 45, 90 degree triangles. So remember, if the side lengths are given to you, then the hypotenuse is, in this case, y is equal to 5 times the square root of 2, which is just 5 square root of 2. Okay, and the next one, we have that we are not given the legs that form these, that are touching the 45 degree angles. So again, if you know the hypotenuse, we know that the hypotenuse is equal to the side length times the square root of 2. So to find the side length, which in this case is x, we would divide by the square root of 2. So s would be equal to 5 over the square root of 2, but we've dealt with rationalizing denominators before, and we have a radical in the denominator that needs to get out of the denominator, so we would multiply by the square root of 2 over the square root of 2 to get a final answer of 5 square root of 2 over 2. Let's look at the next problem. Again, we're faced with a similar situation. We have the hypotenuse, which in our case is y, is equal to the side length, which is 8 times the square root of 2. So our answer is 8 square root of 2. And the next one, we have that the hypotenuse, which is 10, is equal to the side length, which is x, times the square root of 2. So we're going to have to divide by the square root of 2 on both sides. And we get that x equals 10 over the square root of 2. Well, you need to multiply by the square root of 2 over the square root of 2 to give you 10 square root of 2 over 2. That is not your final answer, however, because 10 divided by 2 then reduces to 5. So our final answer for this particular problem is x equals 5 square root of 2. All right, in example 2, we're talking about a 30, 60, 90 degree triangle, okay? And so, again, remember the information that I mentioned. With a 30 degree angle, it goes with the smallest side, which is just 1 or just s. The hypotenuse is double that side. And then the side opposite of the 60 degree angle is side square root of 3. All right, so let's go ahead and refer to those equations that were given to us in our textbook so that we can kind of help answer these questions. So let's try to find the first part. So the hypotenuse is equal to 2 times the shorter leg. All right, so right now what we have is W is equal to 2 times Z. Well, right now we have two unknowns, so we're going to have to come back to that one. So let's go back and look at the other one. It's saying that the longer leg is equal to the square root of 3 times the shorter. All right, well, the longer leg is 4, and that's equal to the square root of 3 times the shorter. Well, the shorter in this case is Z. So now we actually can solve for variables. So let's solve for Z. I would need to divide by the square root of 3 on both sides, giving me Z equal to 4 over the square root of 3. Now, we know that's not rationalized, so let's go ahead and rationalize it. We need to multiply by the square root of 3 over the square root of 3, and that gives us 4 square root of 3 over 3. So that's Z. Now we're going to plug that Z in over here so that we can find W. So W equals 2 times 4 square root of 3 over 3. When you do this, you're just multiplying the tops in like terms only. So 2 and 4 are like terms, so you'll get 8 square root of 3 over 3. And again, here we can't reduce, so we have found now W and Z. Let's look at the next problem. So again, this is a 30, 60, 90. Just be sure that you can identify which parts are what. So 30 goes with just the side. The hypotenuse is always double the side. And the angle opposite the 60 is the side square root of 3. Okay, so to find the hypotenuse again, it is double the shorter. All right, so let's look at the shorter side, or the hypotenuse. The hypotenuse right now is y equal to 2 times the shorter, which is x. We don't have enough information, so we have to come back to it. The other one is that the longer side is equal to square root of 3 times the shorter, because that's exactly what we see. So the longer side is 10, and it's equal to square root of 3 times the shorter, which is x. So to find x, we need to divide by square root of 3. So x equals 10 over the square root of 3. Now we're not done because we need to multiply by the square root of 3 over the square root of 3. So this is going to be 10 square root of 3 over 3. So far we have found x. Okay, now to find y, we're going to have to substitute 10 square root of 3 over 3 into this second equation. So y equals 2 times 10 square root of 3 over 3, which is going to give us 20 square root of 3 over 3. And that's our final answer. Let's try one more. All right, in example 3, again, we're finding the missing legs. What are the given values? All right, so again, the 30, 60, 90. 30 matches with just the side length. The hypotenuse is double the side length, and the side opposite the 60-degree angle is side square root of 3. So again, let's try to set it up based off of what we have done previously. All right, so again, the hypotenuse is equal to 2 times the shorter. All right, in our case, the hypotenuse is 24. It's going to be equal to 2 times the shorter, which right now we just have a. So if we divide by 2, a equals 12. So now we have 12. And to be honest, since these are whole numbers, we don't even have to do another formula to figure out the other. We could honestly just do Pythagorean theorem. But I'm just letting you know that that's an option. But we won't do it just so, or right now we won't do it just so that we can continue working out this problem. So again, here we go. So again, the longer leg then is equal to the square root of 3 times the shorter. So the longer leg is b, and it's equal to the square root of 3 times the shorter, which is 12. So b equals 12 square root of 3. And we are done. Let's look at the next problem. Again, it's all about identifying your sides. So the angle opposite 30 is the side. The hypotenuse is always double that side, and then the side opposite 60 degrees is side square root of 3. So let's start with the hypotenuse. The hypotenuse is equal to double the shorter. So the hypotenuse here is 40, and it's equal to 2 times the shorter, which is b. If we divide by 2 on both sides, we're going to get that b equals 20. Alright, so then the other part is, besides that, we have the longer side is equal to the square root of 3 times the shorter. So the longer side is a, and it's equal to the square root of 3 times the shorter, which is 20. If we, oops, I didn't even divide, sorry. So your answer is 20 square root of 3. And we are done. Remember, guys, if you have any questions, please be sure to come see me for tutoring.